In this video, we tackle the topic of deferred interest rate swaps. Please pause the video, copy the material down into your notes, and then press play, and I'll talk us through it. I thought this topic might be easiest approached via an example. We'll end with the general formula. So in our example, we're going to have a 3-year annual coupon interest rate swap, but it's going to be deferred for 2 years. So it will start at time 2 and it will end at time 5. And the annual coupons will be at the end of each year. So at times 3, 4, and 5. At time 0, we're given the following spot rates for the next 5 years. And we're trying to determine the swap rate. How we solve this might not be much of a surprise to you if you've been happy with the previous videos about interest rate swaps. The hallmark of an interest rate swap is that the value of the fixed rate bond has to equal the value of the float rate bond at the time of the transaction. Otherwise, there would be the opportunity for arbitrage. So the time of the transaction is time 0. So I'm going to have to move these bonds to time 0 to compare them. Now, the float rate bond, as we've seen before, is really easy to value. At any time in the float rate bond's life, immediately following any coupon payment or at time 0, the value of the float rate bond is always just the face value F, because the float rate bond is neither premium nor discount. Right? The coupons are exactly paying the market rate of interest in each period. So at time 2, start of the swap, the float rate bond has a value of F dollars, the face value. And we'll back this up 2 years via the spot rate to time 0. All right. Well, now let's think a little bit about the fixed rate bond. Fixed rate bond has the swap rate C for its coupon rate. So there's coupons at time 3, 4, and 5, fixed rate coupons. And there's a redemption value arriving at time 5 as well. I will need to move these payments back to time 0 and set them equal to the float rate bond value at time 0, which is what we do up here. So on the left at time 0, I have the value of the float rate bond. Its value was F at time 2, backed up 2 years. On the right, I have the fixed rate bond. Coupon payments at time 3, 4, 5, redemption at time 5. All backed up via the spot rates, as we'll see in a couple of steps. All right, well, I could divide everything by F, so those cancel. And from the first 3 terms on the right-hand side, I could factor out the swap rate, coupon rate for the fixed rate bond, C. Okay? At this stage, I can simply throw in the spot rate information that was given to us. The 2-year spot rate was 4%, the 3-year spot rate was 5%, the 4-year spot rate was 5.5%, the 5-year spot rate was 6%. And I can solve for C, and I get 7.331% for my swap rate. Okay? This also presents a way of getting a general formula. Okay? So if I go back to this line, I notice that what's in parentheses looks like it's almost an annuity immediate. Got a dollar payment being backed up 3 years, 4 years, and 5 years. All right? It looks as though it's a 5-year annuity immediate, but it's missing the first 2 payments. So the payment at time 1 and time 2. So I'll subtract off the payments at time 1 and time 2. And this is simply a more efficient way of writing a bunch of dragbacks of piles of money. If you don't like this formula, you could use this, though if I had 14 terms here, it would be a bit tedious to calculate. Okay. All right. However, I get to this line of the statement, and then I can simply solve for C with some algebra. Subtract V spots 5 to the left, and then divide by the material square brackets. Okay? So this suggests a general formula we can use to figure out the swap rate for a deferred interest rate swap. So if I have a swap that's being deferred for K years and ends after N years, which means it's an N minus K year swap, right? Ours was deferred 2 years and ended after 5 years because it was a 3-year swap. So an N minus K year swap. Then the swap rate C is given in general as V spot K years when the interest rate swap began, minus V spot N years when it ended, all over the flip. Present value of an annuity immediate for N years minus the present value of an annuity immediate for K years. All right. Now, the book, the study manual that we're using also calls spot or the V spot by these term P. Okay, so V spot to the K is denoted piece of K in our textbook. And you'll note in the denominator of this second version of the general formula, we're just using the lengthier version of explicitly writing out all the V's that we're using to drag our piles of money back. Okay, so either formula should work for you nicely. Obviously, if you've got a massive number of payments in the denominator, this will be far easier to calculate, especially if your spot rates are constant.